This is the first video of the metals unit, and in this we're going to look at reactivity series and displacement reactions. What we're essentially going to try and do is, hopefully at the end of this we'll be able to put metals in a reactivity series based on observations from reactions. Okay, so let's get started. So we've got two metals here, metal A and metal B. And the first task we're going to try and do is look at these two reactions and decide which is the most reactive metal. Now, let's just look at the observations for a second. The metal bubbles slowly in a test tube. As metal bubbles slowly and the test tube becomes warm is the reaction of metal A, and the reaction of metal B is the bubbles form metal quickly and the test tube becomes hot. Okay, so it becomes hot, this becomes warm, it bubbles quickly, bubbles slowly. Just looking at those two, you might be thinking that metal B is more reactive than metal A. And if they were both reacting with the same substance, I would agree with you. This sounds like it's more reactive. But what we have to do, we have to make a judgment about what they're reacting with. Okay, which of these is the more reactive substance, water or hydrochloric acid? Well, hydrochloric acid is more reactive. So we're not then convinced that this is the most reactive. Sometimes when I'm teaching, I put this in terms of football. Okay, I mean, let's just imagine metal A is Liverpool. Now, if you're not a football fan, I apologise. Okay, but sometimes it helps people understand. Let's imagine metal B is Aston Villa, and I'm a Villa fan. Okay, and it pains me to say that at the time of recording, Villa are propping up the Premiership and Liverpool are leading it. Okay, so Liverpool is a much, much better team than Aston Villa. We're happy with that, aren't we? Yes? Okay, so let's imagine Liverpool is playing Manchester United here. This is Manchester United. Okay, and what we're saying is, you know, Liverpool probably win that, maybe United, maybe 1-0, maybe they'll draw, I don't know. But they're both really good teams. They're going to cancel each other out. Okay, so we're not going to get much of a reaction, basically. But let's imagine Aston Villa are playing, I don't know, Aylsham Town. Okay, bunch of amateurs. Maybe they're quite good. I mean, they're certainly much better than me at football, but they're not in the same standards as a Premiership team. So Aston Villa are going to thump these 7 or 8-0, and that would be a good result for amateurs against a Premiership side. So if you just looked at the score, 7-0 and 1-0, you'd assume that Aston Villa was the better team. But they're not. They're just playing easier opposition. Okay, so that's what I'm saying here. We have to look at the opposition that the metals are facing, the reactants that the metals are reacting with. Hydrochloric acid is a much more reactive reactant than water. Water is very stable. So the fact a metal is reacting with water and the test tube is becoming warm makes that metal very, very reactive indeed. In the same way, Liverpool beats Manchester United. Manchester United are a really, really good team. For a team to beat them, they must be really, really impressive. Okay, so metal A is more reactive because only very reactive things, only very reactive metals will react with water. Lots of metals react with acid. The only way to be absolutely certain is to take a bit of metal A and put it in hydrochloric acid. Having said that, for safety reasons, we may choose not to do it. If it's bubbling with water and getting hot with water, if we put it in acid, it may well bounce back out in our face in flames. So we possibly wouldn't want to do that. Okay, so another way of deciding which is the most reactive metal is to look at a displacement reaction. What's the rule in displacement reactions? Well, the most reactive metal takes the anion. Okay, and let's give that. Let's look at an equation now and try and explain that. Zinc and copper sulfate. Okay, now zinc is higher up the reactivity series. That's the most reactive metal. Copper is lower down the reactivity series, so that's the least reactive metal. And the sulfate is the anion, and anion is a negatively charged ion. So basically, zinc and copper are competing for this sulfate. Now the rule is the most reactive metal takes the anion. Well, zinc is the most reactive metal, so it's going to take the copper. So we're going to end up with zinc sulfate and leave the copper on its own. Now, because that happens, we can say with absolute certainty that zinc is more reactive than copper. If we were adding it the other way around, I don't know, say zinc sulfate and copper, well, the most reactive metal this time we're still zinc. The most reactive metal already has the sulfate, and copper is the least reactive metal, so that would be a no reaction. You could add those two together and you would see nothing. If you add these two together, you see a reaction. We'll look at that more on the next page. So, look at the reactivity series. Here's a reactivity series. And these reactions. Where there is a reaction, complete the equation. And where there isn't, we'll write no reaction. So zinc and copper sulfate. We've just done that one. Zinc is above copper in the reactivity series. So we are going to get zinc sulfate. And copper as a result. Next one, magnesium and zinc nitrate. Well, which of these is higher? Magnesium is higher than zinc. Okay, so magnesium is going to take the partner as follows. So it's going to be magnesium nitrate, leaving zinc all on its own because it's the least reactive. Copper and zinc chloride. Well, zinc has got the partner, the chloride, the anion. So there is zinc above copper. Okay, but zinc already has the anion, so that's going to be a no reaction. The copper is not going to take it away. And you can have a go at finishing those on your own. Right, so in lesson now we would do this practical. We'd take some copper sulfate and we'd react it with the zinc. We've looked at that already in the last couple of questions. Okay, so what would we see? Well, let's go back to this reaction equation here. Okay, well, copper, where is it here? Here it is. Copper is produced. Now, copper is a red-brown metal. Okay, zinc is a silver metal. So you may see, if you've put a little bit of zinc in, the zinc starting to dissolve. We would use an excess in the reaction. So possibly still be a little bit of that left. But we would definitely see this red-brown metal appearing. Now, copper sulfate solution, that's a solution, it's aqueous. Okay, that is blue. And zinc sulfate, that is colourless. So the blue solution would start to go colourless. There's an observation. And we'd also get that red-brown metal being produced. Whenever we're looking for observations, have a look at what the products are, because you'll see those. Okay, so observations. 1, red-brown precipitate. A precipitate is a solid being formed in a reaction, and that is because that is the copper being produced. We also then get the blue solution, which was copper sulfate, turns colourless, and that's the zinc sulfate. Reaction equation, we've done that before. Let's quickly do it again. We said copper sulfate, blue, reacts with zinc, which is silver, okay, and then those two produce zinc sulfate, which is colourless, so the blue solution goes colourless, and leaves copper on its own, the red-brown metal. Okay, and we've explained that already. So let's quickly now look at trying to establish a reactivity series from a lot of observations. So we've got reactions here with water, acid, and then we've got a couple of displacement reactions. Reaction with silver nitrate and reaction with gold sulfate. So first thing we have to decide is which of these is the most reactive. Well, acid is more reactive than water, so if a metal is going to react with water, it has to be incredibly reactive. So we're going to look at these first because water is the least reactive reagent. Okay, so as we go down this list, okay, we've got reactions here, 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 okay, and here. So we just need to look at these in turn. Metal reacts immediately, moving around the surface of the water. It gets so hot the gas is given off, it starts burning. So we've got gas burning there. Do we have gas burning on any of those? Extremely small bubbles? No. Metal reacts vigorously once it melts and moves around the surface of the water, rapidly giving off a gas but not burning. Bubbles quickly form. Okay, so the gas burning is only an I, so I is the most reactive, therefore we're going to say I is at the top of the series. Let's put I right at the very beginning, so I probably is going to be potassium. Okay, potassium. Okay, next one down then was D, because this one, the metal moved around the surface of the water, rapidly giving off the gas. So D is going to be second, and that's going to be sodium is second on the list there, so let's write sodium there. Okay, our next one was bubbles quickly forming on the surface, because B is extremely small bubbles seen slowly appearing. So this E is going to be more reactive on the basis of the observation than B. Therefore, E is going to be calcium and B is going to be magnesium. E is calcium and B is magnesium. Okay, right. So that's how we could do the top of the reactivity series. Now we could start at the bottom as well, I suppose. We could start at the bottom by looking at these displacement reactions. Okay, reaction with gold sulfate. Well, gold is right at the very bottom, so we'd expect everything to react with gold sulfate, apart from the very least reactive on the entire system. So there's a no reaction with gold sulfate, C. So C is going to be right at the very bottom of the reactivity series. Right at the very bottom is gold, so that one's going to be gold. Next up is silver. Well, we're now looking for another no here. Now, everything is going to react with silver nitrate, apart from gold and apart from silver. We've already got gold out, so let's find another no reaction. There it is there. So F is going to have to be silver. F is going to have to be silver. Okay, so we've now got A, G, H, and J to go. Okay, so let's look at our reactions with acid. So we've got, what did I say we've got to go? We've got A to go, we've got G to go, we've got H to go, and we've got, what did I say was the last one? J to go. J. So J says bubbles form slowly on the surface of the metal. This one says no reaction initially, so that's not very reactive, is it? But on revisiting 1 hour later, very small bubbles. Well, I think that's going to be fairly low. Okay. A is a no reaction. All right, so that's a no reaction totally. And G is extremely small bubbles can be sorted. So I think A is going to have to go there, isn't it? So the next one up was copper. So that's going to be, copper is going to be A. So we've dealt with copper. Okay, so we've got extremely small bubbles can be seen appearing slowly, therefore G. We've got no reaction initially observed, but come back an hour later with something, and we've got bubbles form slowly. So we've got bubbles form slowly for J. Extremely small bubbles can be seen slowly appearing. So extremely small versus bubbles slowly. I think this is more reactive. Okay, so J is the next most reactive. So after B, which was magnesium, comes J. So after B, magnesium, comes aluminium. So aluminium is going to be, what did we say? We said G, didn't we? Aluminium. Therefore, J comes next. Bubbles form slowly, so J is going to be after aluminium. Well, carbon's not a metal, so zinc. So zinc. And that just, so we've done G, and we've done J. So, we've got H to do. H, no reaction initially observed, but on revisiting an hour, so H is our last one, hopefully. And it is. So H is going to be iron. And that's how we put a reactivity series together through observations with other reactions.